Okay, guys, so in this video, we are continuing to talk about rational functions, and we want to talk about how to simplify them. So we're going to start our simplification of fractions topic. So general idea is this. If you have a rational expression, so basically you have something divided by something else. If there is a factor that repeats in both the top and the bottom, that factor can be canceled out and a rational expression can be simplified. So this is true all the time. So basically this will just be b divided by c. So example of that would be something like this. Let's say I have 2 multiplied by 3 and over here I have maybe 2 multiplied by 5. So it turns out that 2 can just be canceled and the answer is 3 divided by 5. So you can check that out. That's actually not that hard to show. But one thing that I want to make a word of caution is that sometimes what people do, and I want to warn you so that you do not ever do something like that, is that they think that this property extends to also something like addition or subtraction. And the answer is it does not. So if I had the same exact expression, but I had something like 2 plus 3 divided by 2 plus 5, and if I thought, oh, I can just cancel 2 because I see it on the top and on the bottom, and that becomes a 3/5. So if you think that's true, that is completely not true. Okay, and you can always actually check that out. Since you have a calculator, you can actually say, okay, well, 2 plus 3, that's a 5, and 5 divided by 7, is that really equal to 3 divided by 5? And you will know that that is absolutely not true. So you can never do this kind of thing where you cancel if you don't have a multiplication. So it has to be times both the top and the bottom. Okay, so I'm going to show you some of these exercises in the Dismas activity, and I want to have them side by side, because since you're going to have a calculator, you should be able to also figure this out by just simply using a calculator. So if you just have fractions that have no variables, it's very easy to simplify using this calculator. Let me show you how. And of course, I can also show you how to do this by hand. So maybe like I just take one and show you how to do it by hand. But generally, since you have a calculator, you really don't need to know how to do it by hand. So let's say I want to simplify a fraction 4 divided by 10. So what I have to do is I have to know that 4 is the same thing as 2 times 2, and that 10 is the same thing as 2 times 5. And so I can see that there is something repeating on the top and on the bottom. I can cancel that and I can get 2/5. So that's basic idea of simplifying fractions. But in this course, I don't care whether you can show me, not show me, use a calculator. What my focus is going to be is what happens when you have variables. That's what I will be focusing on. So just to show you what the simplified version looks like, what I would do here is I would press 4, division, 10, enter. So it's going to give me a decimal, so it gives me 0.4, but I want the simplified fraction. So there is a button that is right above the enter, which is like, it looks like 2 arrows pointing left and right, and I'm just going to press that. What that does, it reduces the fraction for you. So it tells you that the answer is 2/5, okay? And I will do the same thing, similar stuff over here. So let's say I want to simplify 9 divided by 39. So I enter that. It gives me some ugly decimal. That's not what I'm after. I want a simplified fraction. So I'm going to press that double arrow thingy, and it tells me that's the same as 3/13. So that's basically it. So continuing in the same fashion, you would see that that's the same as 2/5. This would be the same as, I think, 11/2, something like that. Okay, so with numbers, there shouldn't be a question because you can do this on a calculator. Now, what happens when you have variables? That's a different story. Okay, so I want to take a look at each one of these questions separately. First thing I'm going to do is every one of these, if you do have just the numbers on the top and on the bottom, and you can try reducing them first on a calculator. If they're not reducible, then you're just going to repeat them in the final answer. So for example, 3 divided by 13. So first ignore the variables, just enter whatever happens without the variables and see if you can reduce it and get something different. Well, here it's not. It's just giving me 3/13. So that's going to be part of the answer. 3/13 is not going to go anywhere. In the second expression here, the top doesn't have any number, so you can think of it as 1. The bottom has 8, but 1 divided by 8 cannot be reduced, that's for sure. Now, for this one, though, this is actually, I think we can reduce it. So if I go to the calculator and I divide 6 by 21, I will actually see that that is reducible because the top and the bottom share a 3. So it is going to be 2/7. So the answer will have a 2 on the top and a 7 on the bottom. Plus some stuff with the variables, which we're going to discuss in a second, but at least we know what's going to be the number part. Same thing on the last one. The 65 divided by 15 can be simplified, which we should do, and we will see that that is the same thing as 13/3. But what about the variables? So let me explain what will happen with the variables. Okay, so let's start with the first example. So this is going to be 3x divided by 13x. So remember that I said that 3 and 13 are not reducible, which means that the final answer has to have a 3 on the top and 13 on the bottom. They are not going to go anywhere. They're going to stay the way they are. But what I see is I see a x and an x, which is some number, right? And it's multiplied by, because remember the default operation is multiplication. It's multiplied by the numbers. So whenever something is multiplied and it's the same in the numerator and denominator, it can be canceled. So you can just cancel that. So the final answer is basically 3/13, and that's it. Okay, now let's look at the next example. So for the next example, we've got x squared divided by 8x. So first thing first, we did talk about that the numbers are not going to go anywhere because 1/8 is not reducible. So 8 is going to be on the bottom. I can write 1 on the bottom, or I can just skip it. So I'm going to skip it because normally we don't write 1, because 1 times anything is just the same thing as that something. However, if you get nothing left, if like everything cancels out, then make sure you put a 1 on the top. So at this point, I'm just going to put it, and later on I can get rid of it. Now, what happens with x squared divided by x? Here's what happens. What you're going to do is think of x squared as x multiplied by x. And then you have a bottom of x. So you can see that one of those x's is going to cancel out because it repeats on the top and on the bottom. The other x is not, so it's going to stay, and it's going to stay on the top. So that's my final answer. Now 1 times x again is just x. So my final answer here would be x divided by 8. Okay, so if I also want to do the next example, which is 6x squared divided by 21x. Okay, so first I need to reduce the numbers, and we've already done that. If I go back to my calculator, you can find it. I think at some point I was reducing 6/29. I mean over 21, sorry. And I think I was getting 2/7 there, right? So 2 will stay on the top, 7 will stay on the bottom. Now regarding the variables, again, it's the same exact thing. X squared is x times x, and then there's one x on the bottom, which will cancel, and so there'll be x left on the top. So that's my answer going to be on for the third example. Okay, for the last example, I've got 65x squared divided by 15x to the 7. So again, I reduce 65/15. It can be reduced, and I believe that's 13/3, so that's going to stay. But what about the variables? So in the case when you have something like x to the power 7, it just gets too much trouble to write it all out. So what you would have to understand is x squared is the same as x multiplied by x, but x to the 7 is x times x, and so on 7 times. So at some point you're going to see what happens here. So 2 of these x's are going to disappear, but the rest will stay. And there's 5 times x is multiplied by itself, and that's the same thing as x to the power 5. Now, writing it out actually is not necessary. What you have to think about is this. Look at the powers on the top and on the bottom, and just subtract them. So if the larger one is on the bottom, that's where the answer is going to be. So x to the 5 will be on the bottom because 7 minus 2 is 5, and the larger number was on the bottom. That's why I have x to the 5. However, if, for example, I wanted to simplify something like this, let's say I had x to the power 6 divided by x to the power 2. So again, what you do is you subtract the powers, and you keep them wherever is the larger one. So if I subtract 6 and 2, I would get a 4, and it's going to stay on the bottom. Now, I'm sorry, on the top, because the larger one is on the top. On the bottom, you're just going to be left with 1, right? Because there's nothing else left. Now, however, division by 1, you don't have to do. So because when you're dividing by 1, it's the same thing. So this is just going to be x to the power 4. So similarly, if I have something like x to the power 6 divided by x to the power 20. So what do I do? Well, I subtract the powers. So 20 minus 6 is 14. And the wherever was the larger power, that's what the answer is going to be, and the other part is going to be 1. So there's nothing left, that's going to stay as 1. Sometimes it could be a little bit trickier. So for example, let's say you have x to the power 4 divided by x. So x is the same as x to the power 1. You need to know that. And so when we subtract the powers, you're going to wind up with x to the third. And then yes, you can divide it by 1, but you can just write it as x to the third. All right, so that's it as far as canceling x's.